have to learn all of this stuff? Because I know sometimes you read things and you think, why? Why? Okay. These drugs, again, are pervasive. We use them in dentistry. We prescribe drugs that interfere with them. Some are very, very closely related to what we do. And also, there's going to be other drug groups that we learn about that have ANS, autonomic nervous system effects. So when I say to you it has an anticholinergic effect, you don't go, what does that mean, okay? You will know what it means, okay? And just knowing that that group of effects that drugs like this can have will help you understand a lot of other drugs, okay? Drugs that we administer ourselves, vasoconstrictors, epinephrine, which we've already talked about, okay, also known as adrenaline. That is an ANS drug, right? Drugs that increase salivary flow, like pilocarpine, and another one that we'll talk about, is an ANS drug. So two things that have direct effect on what we do with what we either administer or what is prescribed in the dental office. Okay, really, really important. We know that anticholinergic drugs, and we'll say to you that this drug has an anticholinergic effect because of the way it affects the autonomic nervous system. They tend to cause xerostomia, okay, dry mouth, and we know that that affects us greatly because it doesn't just mean people have a dry mouth and complain about it. It means that they're at increased risk for caries and all of those kinds of things, okay? So, again, very, very vitally important. The anticholinergic effect that they have, again, is pervasive, and it also goes along with some medical problems. Have you ever heard of Sjogren's syndrome? Okay,
Yes.
you will treat, some of you probably have, you will treat people that have this. It can be a very devastating disease. It can affect people in different ways. Some people have it in a very mild way, some have it in a very dramatic way. So these are patients you're going to be dealing with, every week, every day. Just to review really quickly for you, and I did post some information in reviewing the systems for you, is that the nervous system in general is divided into two major parts. The central nervous system, which is going to be your brain and your spine, okay? The peripheral nervous system, which is divided into the autonomic, okay, or automatic system, and the somatic, which is voluntary movement. And remember, when we talk about motor, when we're talking about nerves, we're not always talking about movement, we're talking about action, okay? But in the case of the somatic system, we are talking about movement, voluntary movement, okay? And what we're talking about today is the autonomic nervous system divided into the parasympathetic, there's actually longer words with this, the parasympathetic autonomic nervous system, and we call it the PANS, it helps us to remember it. And then we've got, bless you, the sympathetic autonomic nervous system, which we call the SANS, okay? And those little words are going to help us to remember what these things do, okay? I got my usual fun ways for you guys to remember stuff, okay? Autonomic drugs, okay, that we'll talk about. There's 4 different groups that we'll talk about. Affects the autonomic nervous system in the PANS and the SANS, okay? And like all drugs, okay, that we've been talking about so far, the ANS drugs either act like what our body would do or block what our body would do to one extent or another, either overall or selectively, okay? Same thing. We're going to talk about the anatomy of this system and the differences between the PANS and the SANS, and then it will help you to understand why they do what they do. The functional organization of both, the neurotransmitters, which are the little messengers, okay, that insert themselves into this process in all our body processes, and then how do drugs affect the neurotransmitters or act like neurotransmitters, okay? And then the 4 different drug groups. If you haven't figured it out already, okay, the autonomic nervous system is something that happens in the background. We don't sit there and say, okay, like here, raise my hand, let me raise my hand. But we don't generally sit there and say, okay, heartbeat faster, heartbeat slower, okay? GI, start moving yourself or stop moving yourself, okay? We don't do that. Some of our thoughts can have an effect, okay? But in general, it's kind of the background stuff that's happening, okay? We don't tell our heart to beat. Although I guess there are people that can meditate and make things slow down or whatever, right? But we generally don't do that. So it regulates things like our blood pressure, okay? Heart rate, our GI motility, okay? Our salivary gland secretion, okay? And these things can be stimulated by the mind. We smell food and we salivate, right? All right? Our bronchial smooth muscle, okay? How much our lungs contract and expand. And it relies on these specific neurotransmitters, okay, and the receptors, right? We already talked about these. So the neurotransmitters go out there and they affect the receptors directly, or they affect how other things attach to the receptors. And then we get that response at the target tissues or target organs. Okay, that's how that whole messaging system happens. And we've already talked about that a little bit, but now we'll talk about how it happens with this, and you'll understand why we learned that background information as well. So if you remember nothing else, remember that autonomic equals automatic. Okay, it's the things that automatically happen within our body in response to other things. In both divisions of the autonomic nervous system, so the PANS and the SANS, okay, they have sensory fibers, okay, the neurons, that are afferent and efferent, okay? So the afferent ones sense something, okay, and in our CNS, they kind of say, oh, what's happening out there, okay? What's happening out there? Oh, I'm hot, okay? Something's affecting me. Afferent, it's affecting me. I'm hot, I feel hot, all right? Then you've got your central integrating system that says, oh, what happened there? You know, what's happening, okay? What did you find out, okay? What are we gonna do? Then the efferent sends a message to the efferent part of the neuron that goes back out and says, do something, okay? Begin sweating, okay? So we get hot, right? And then we get this message to our central nervous system, and then it says, oh, I'm being affected by this. What effect am I gonna have? I'm hot, I've gotta cool down the body. Let's start sweating, okay? And all of that happens through the little messages that go through our brain and through all of our neurons, all right? It's magical, if you will. And then we start sweating and our body gets cooled down, okay? It's a very simple explanation of that, but that's precisely what happens, okay? So what's the effect on me, okay? I'm hot, my CNS realized that I'm getting overheated, okay? It tells me to start sweating, and all of that happens through all kinds of neurotransmitters and then affecting our sweat glands, okay? And then we start perspiring and then it cools down our body, okay? Begin sweating, okay? And then what effect did it have on me? I was hot and I started sweating. And all that happens without us even thinking about it. And even though we don't like perspiring, okay, it does help us to cool down. Okay, so we need to look at the anatomy of the neurons, and we know they're slightly different in the PANS and the SANS, and there's a reason for that. Okay, and we have that preganglionic neuron. What does that mean? Okay, it originates in the CNS, in the central nervous system, okay, and it passes out, and then it forms ganglion or connections, and it synapses with not just one, but a number of different postganglionic neurons, and this can happen preganglionic, postganglionic, okay? Neuron to neuron to neuron to neuron until we get to the organ that it affects, the tissue or the organ that it affects, okay? So we already know the space between the preganglionic and the postganglionic, right? It's called a synapse or synaptic cleft, and that's where some of the magic happens. The postganglionic neuron starts from the synapse and ends eventually at the effector tissue. Again, some of the neurons synapse with each other, but eventually we get to that last one and it ends at the effector tissue, okay, where the action's gonna happen, okay? That's the target tissue. And we know that there's a difference, again, between the PANS and the SANS, okay? So preganglionic fiber is in the brain. The neurotransmitter carries the message across the synapse, and the postganglionic fiber releases the neurotransmitter to send the message to the organ or tissue eventually. So this is kind of like, that's why I have the stick figure. This is the stick figure version of it. This is neither PANS nor SANS, okay? It's just a general one. Autonomic nervous system, preganglionic fiber, we got the synapse, postganglionic fiber, okay? And then the effector tissue. I don't know what that is, a piece of muscle or something or whatever it is, okay? That's just a very general stick figure version of what happens there. And then we'll see the differences between it. Now in the PANS, okay, in the parasympathetic autonomic nervous system, the cell bodies in the CNS, okay, we've got that preganglionic fiber coming out, of the parasympathetic originate in these different nerves. You don't have to like actually memorize the nerves, but you're gonna know what these do, okay? We've got 3, 7, 9, and 10, okay? Let's think about these. 3, ocular motor. 7, okay, is going to be your facial. 9, glossopharyngeal, okay? 10 is vagus, which is very very complex, okay? But some of those directly affect what we're talking about, what we do in our practice every day. In the pans, the preganglionic fibers are very long, okay? They extend almost to where the tissue that they're going to affect is, okay? Which leads to a discrete response. What do we mean about discrete?
Not that noticeable.
It's what?
Not that noticeable, or like.
It's, I guess you would think of it that way, but it would be, when we talk about something being discrete, this is how I like to think of it. If someone gives you a message and they tell you to kind of keep it quiet, okay, and only tell a few people, you're being discreet. Okay? So that's a good way to remember it. It means a very specific response. Okay? It has less ganglia out there, so it's a very specific response. It affects less tissues. Not less important, but less tissues, okay? So in that case, because the preganglionic is long, the postganglionic is short, and it synapses with fewer postganglionic fibers. And the responses are discrete, okay? Very specific, okay? The innervated tissue. As opposed to the sympathetic autonomic nervous system fibers, okay? The cell bodies there, okay, they span from, and by the way, with the previous, and we'll go over this again too, with the parasympathetic, okay, we're talking about up here and down here, if you're looking at the spine, and we'll look at a picture of that. So they're kind of at either end of the body, okay? When we're talking about the sympathetic autonomic nervous system, okay, the preganglionic fibers are in the thoracic and the lumbar area, so sort of in the middle here, okay, sort of in the middle here. The preganglionic are shorter, okay, and they synapse with more postganglionic fibers. So they have a diffuse response, okay? They affect more tissues in the body, okay? A diffuse response. And one of the ways, I think it was a student that helped me to remember this, she said with the parasympathetic, with the pans, they're kind of like pants, okay? So they're long, all right? Whereas the SANs, where are we? The SANs are short. Oh, I'm backwards. Like shorts. That just helped to remember it. I've got more for you too. There's more where that came from. Okay? But there are, what's important to remember, I always think of the SANs as like my fingers, like with a whole bunch of them, and they're short and they're up here or something, and then they're long, then they go out. I don't know. I make all these pictures in my brain. Okay? But they're short, but they synapse with more. Okay? Multiple synaptic connections, diffuse response. You have a question?
And is this happening or start at the beginning?
What does what happen?
The sands, like, are they both in that beginning phase, or
There's no phase. What we're talking about is the way that they're made. The anatomy of them is such that the pans has long fibers, okay, but they sit in lesser synapses and very discrete responses. Fewer things that happen. The SANs are shorter to start with, and then they have long ones that go all the way through the middle part of the body. That's all you have to remember, because then when we talk about them, you'll understand what they affect. Yes?
So the pins start, it's on the CNS, but it's in the brain, just the brain? Or
Both
brain and
the
spinal
pans
cord?
and the SANs start in the central nervous system.
But it's no specific, because somehow I thought the book says that one of them is in the, it's spinal cord, the other one is brain and spinal cord.
Everything happens through the brain and then goes through the spinal cord,
Okay.
okay? And then once you're in the spinal cord, and then the nerves go out from there, where they synapse is different, okay? But remember this, that most tissues have effects, most, not all, have effects from both the pans and the SANs, eventually, okay? Because of the neurotransmitters and all of that. So I can't simplify this too much, but I just want you to remember this anatomy for when we talk about the types of responses that they have and what tissues they affect when they're stimulated, okay? Okay. Within the central nervous, the SANs, okay, the sympathetic autonomic nervous system is the adrenal glands, and we'll go over where that is, okay? The adrenal medulla, okay, the adrenals are the little glands that sit on top of the kidneys, okay? Let me show you. Sit on top of the kidneys, okay? So there's your kidneys, and the adrenal glands are sitting on top of there, okay? And this is a cross section of it, okay? We know the adrenals are endocrine glands. Hormones are produced there, all kinds of stuff happen. In the middle, the medulla, which is in the middle, okay, of there, it actually acts like a ganglion, a nerve ganglion. And I love this picture isn't in your book. I love this picture because it shows, you see the cross section of the spine in the center there? It shows the preganglionic sympathetic neuron, okay, going from the central nervous system, from the spine, into the adrenal medulla, okay, where it then synapses, okay, and the postganglionic fiber comes out of there, okay, because what it releases there is what?
Epinephrine.
Epinephrine and norepinephrine, really important. So that's like it's like a major, it's like a Mongo sympathetic ganglion that happens in the adrenal medulla. Okay, really important. Hormones that are submitted from there, our neurotransmitters, are going to be our norepinephrine and our epinephrine, and then it releases. And one of the major effects it has is on the blood vessels. Okay, so epinephrine is dumped into the blood vessels and then to the target tissues, and that's where it happens. So we remember the sympathetic nervous system, epinephrine and norepinephrine, and we remember where that happens. It's really easy to picture how important that is, okay? So the adrenal medulla is innervated by the sympathetic preganglionic fibers, okay? It's like a large ganglion that happens in there. When the sympathetic autonomic nervous system is stimulated by our body or by drugs, okay, which act the same way, it releases epinephrine and norepinephrine into the blood system, into our systemic circulation. Do you see how that alone can have like a general diffuse effect? Even just epinephrine and norepinephrine, okay? So that's a really vital, important part of it, and I hope this helps you to understand how that happens. In talking about how these different subdivisions of the autonomic nervous system work, if you look at the top here, and again, this is from your book, you look at the cervical area, the neck area, okay? And that's where those different vertebrae are that are going to be the parasympathetic nervous system, and down here as well, okay? So up here and down here, okay, so head and tail in a way. And then we've got the SANS, the sympathetic autonomic nervous system, in the middle, okay? And that, again, is going to include the adrenal medulla, all right? So PANS up here, down here, SANS in the middle there. This drawing, this picture I got from another website, which I thought was really, really helpful, and it actually gives you the organs that it helps to innervate, and I just think it's a beautiful picture that helps you with that. So if you look at the parasympathetic, okay, you can see things like stimulation of flow of saliva, okay? We can see that it does. Do you see how they have effects on the same organs, okay? So when we're talking about the parasympathetic, we'll be talking about this again. Slower heartbeat, constricted bronchi, secretion of the peristalsis, or all the things that control the GI secretions, okay? Stimulation of bile, all right? Contracting the bladder. Sympathetic's going to be almost like the opposite, okay? We'll talk about this in detail. But they have effect on the different organs, okay? But from a different point of view, and different neurotransmitters and different effects on them, sometimes very, very opposite, okay? And there's your adrenals, okay, with your sympathetic nervous system in the middle there, all right? Okay, so functionally, they can often act opposite of each other, okay? The yin and the yang, even your book calls them that. The PANS and the SANS tend to act in opposite directions, right? We say that the PANS primarily is concerned with conserving your bodily processes, okay, and conserving energy in order to put its energy into your bodily processes, so it's your rest and digest system, okay? Rest and digest. Your digestion, your intestinal tract motility are greatly influenced by the parasympathetic autonomic nervous system, by the PANS. Whereas your SANS is your fight or flight, okay? We all know what that feels like, okay? Our fight or flight system. And they argue with each other sometimes, right? So you're sitting there resting, and all of a sudden you see a mouse, okay? So you go from one to the other very quickly, all right? It's very disturbing.